Welcome to my extra classes. Let's learn without limitations. Hello, this is Shivani, and today I will be explaining everything about the Amazon Elastic Load Balancer service. In our discussion, we will be focusing on the concept behind Amazon ELB, types of ELB and its advantages, listeners, and configuration of Amazon ELB service. At last, Nishant will be taking you to the live demo of the implementation of the application load balancer on AWS console. So, let's get started. Elastic Load Balancing is a highly available service that distributes traffic across Amazon Elastic Compute Cloud, Amazon EC2, instances and includes options that provide flexibility and control of incoming requests to Amazon EC2 instances. An advantage of having access to a large number of servers in the cloud, such as Amazon EC2 instances on AWS, is the ability to provide a more consistent experience for the end user. One way to ensure consistency is to balance the request load across more than one server. A load balancer is a mechanism that automatically distributes traffic across multiple Amazon EC2 instances. You can either manage your own virtual load balancers on Amazon EC2 instances or leverage an AWS cloud service called Elastic Load Balancing, which provides a managed load balancer for you. The Elastic Load Balancing service allows you to distribute traffic across a group of Amazon EC2 instances in one or more availability zones, enabling you to achieve high availability in your applications. There are several advantages of using Elastic Load Balancing. Because Elastic Load Balancing is a managed service, it scales in and out automatically to meet the demands of increased application traffic and is highly available within a region itself as a service. Elastic Load Balancing helps you achieve high availability for your applications by distributing traffic across healthy instances in multiple availability zones. Additionally, Elastic Load Balancing seamlessly integrates with the auto-scaling service to automatically scale the Amazon EC2 instances behind the load balancer. Finally, Elastic Load Balancing is secure, working with Amazon Virtual Private Cloud, Amazon VPC, to route traffic internally between application tiers, allowing you to expose only internet-facing public IP addresses. Elastic Load Balancing also supports integrated certificate management and SSL termination. Elastic Load Balancing provides several types of load balancers for handling different kinds of connections, including internet-facing, internal, and load balancers that support encrypted connections. There are three types of load balancers we have in AWS. Number 1, internet-facing load balancers, 2, internal load balancers, and number 3, HTTPS load balancers. An internet-facing load balancer is, as the name implies, a load balancer that takes requests from clients over the internet and distributes them to Amazon EC2 instances that are registered with the load balancer. When you configure a load balancer, it receives a public DNS name that clients can use to send requests to your application. The DNS servers resolve the DNS name to your load balancer's public IP address, which can be visible to client applications. In a multi-tier application, it is often useful to load balance between the tiers of the application. For example, an internet-facing load balancer might receive and balance external traffic to the presentation or web tier whose Amazon EC2 instances then send its requests to a load balancer sitting in front of the application tier. You can use internal load balancers to route traffic to your Amazon EC2 instances and VPCs with private subnets. You can create a load balancer that uses the SSL/Transport Layer Security (TLS) protocol for encrypted connections, also known as SSL offload. This feature enables traffic encryption between your load balancer and the clients that initiate HTTPS sessions, and for connections between your load balancer and your backend instances. Every load balancer must have one or more listeners configured. A listener is a process that checks for connection requests, for example, a CNAME configured to the A record name of the load balancer. Every listener is configured with a protocol and a port, client to load balancer, for a front-end connection and a protocol and a port for the back-end, Load balancer to Amazon EC2 instance, connection. Elastic Load Balancing supports the following protocols: HTTP, HTTPS, TCP and SSL. Elastic Load Balancing allows you to configure many aspects of the load balancer, including idle connection timeout, cross-zone load balancing, connection draining, proxy protocol, sticky sessions, and health checks. Configuration settings can be modified using either the AWS Management Console or a command line interface, CLI. I request you to please pause the video and take time to read the definition of all the configuration options available on AWS. Now, Nishant from my extra classes will take you to the demo part where he will demonstrate to you how can you create and implement an application load balancer in AWS.
Thank you, Shivani, for explaining all the key concepts behind Amazon ELB. Hello everyone. Before going to the AWS console, let me first give you an overall overview of the activity we are going to perform. First, we will be creating a VPC and two subnets inside it in different availability zones. Then we will create a route table followed by an internet gateway which will be getting attached to the VPC. After that, we will deploy two EC2 Linux instances in each subnet. As soon as both the instances are up, we will install an Apache web server on each EC2 instance for the demonstration. We will create an index.html, a static sample application page, on both the web servers. Then, we will try to access our application through a web browser using the public IP addresses of each instance. The next step is to create a load balancer and add these servers to it. When this is done and if everything goes fine, we should be able to access our application through the DNS associated with the load balancer in the web browser. So, without waiting further, let's log into our AWS Management Console. Welcome once again to the AWS console. As we discussed, let's go ahead and create a VPC. Here, I am going to create a VPC named ELB test-VPC with CIDR block 10.0.0.0/16. You can choose any block of CIDRs per your interest. Now, since our VPC is ready, let's create two subnets inside it. As soon as both the subnets get created, we need to have an internet gateway attached to the VPC. After that, we will create a route table for the VPC we have created and will get additional rules added to the route configuration for the internet gateway. Here, I am creating both subnets in different availability zones. However, if you wish you can have these created in the same availability zone as well. Both the subnets are available now. Let's create an internet gateway to allow connection to this VPC through the public internet. As you can see, I have created an internet gateway ELB test-gateway. Once you create a gateway, the status will be in detach mode. We must have to attach it to a VPC. Here, I am going to attach it to our ELB test VPC. Once all is done, we will go ahead and create a route table for this VPC. We will define the routing rules in the Route Configuration tab of the table. Here, we could see there is only one rule added for the local connection. Since there is an internet gateway available and attached to the VPC, so we have to add a rule to allow connection through this gateway. After adding the new rule for the gateway, we need to associate the subnets we created to this route table. We can do it in the Subnet Association tab. Congratulations, we have completed the creation of infrastructure as our first step. In the next step, we will create two EC2 Linux instances in both subnets. While creating the instances, you must be careful and choose the correct VPC and subnets, as in this case ELB test-VPC for our demonstration. I hope you are already aware of how to create an EC2 Linux instance in AWS console. If you have any questions on deploying EC2 instances over AWS Cloud, please leave your concern in the comment box. We will try to get back and help you out as soon as possible. Now, I am creating two EC2 instances in two subnets. The instances should accept HTTP connection as we need for this test. So, in the security group configuration, please don't forget to add a rule to allow HTTP requests. Now, when all the configurations have been done, while launching, AWS will ask you to create a key pair which will be used to make an SSH connection to your instances. Here, either you can create a new key pair or use an existing one. But, make sure the existing key you have chosen is available with you. For this demonstration, I am creating a new key pair named ELB test-key pair. As soon as you will create on launch button after downloading the key, the background process of instance creation will start and you will be able to see the status in the EC2 dashboard. Since I am done with creating a Linux instance, let's go ahead and create one more quickly. I am fast forwarding this section, as we are already aware of the process. The only difference is that we will create this second instance in another subnet. Both instances have been created successfully. So, let's connect to the instances one by one using SSH. I have used the same security groups and key pairs for both instances in my case. But, you can have different security groups and key pairs for individual instances. As soon as our SSH connection to both instances is established, we will do a formal health check using top and df-kh command. I will update whatever Linux commands I will be using in the description. Now, we will switch to root user and run another Linux command, that is yam update. It will automatically update all the presently installed packages on our EC2 instance to their latest versions. The update will take few minutes, so I am fast forwarding this section to save our time. The update has been completed on both the EC2 instances. Now we will go ahead and install Apache web server using yam install httpd command on both the nodes. Once Apache is installed, we will check the status using a Linux command, that is systemctl stas httpd. Since we have not started the web services yet, it will display the running status as inactive or dead. Now, let's start Apache web services on both the nodes using the command systemctl start httpd. When we check again the status of Apache, it should display the stas as running. Now, since Apache services are up, we will create an index.html file in /var/www/html directory on both instances. Here, I have a sample HTML code that I am going to update in the index.html file. Since I have to update the codes on both the servers, hence, I am just masking a small display text change in both the codes to differentiate amongst these instances. Now that our index.html pages are available on both the EC2 instances, hence, let's try to access our sample application using the server public ID addresses. Here, you can see our application is accessible through the web browser. Our next step is to create a load balancer for our web application. So, let's go to the EC2 dashboard and start creating an application load balancer. Here, I am creating an internet-facing load balancer with the name myExtraClasses and IPv4 address type. After selecting appropriate options in basic configuration, let's move towards network mapping. In the network mapping, we need to select the correct VPC, which we have created for this demo. Also, we will have to select all the availability zones where we have our subnets created. In this case, AP South 1A and AP South 1B. After selecting the OSs, we need to configure the security group for his load balancer as well. Here, either you can create a new security group for ELB or select an existing one. I am going to select the same security group which we have created for our EC2 instances. Listeners and routing is the last configuration we are required to complete. We already have HTTP listeners available, so we need to create a target group with both the EC2 instances registered to it. Since we don't have any target group created, I am going to create one now. We are going to target our instances, so we need to select the target type as instances. Also, we need to select the VPC we have for this ELB test. Now, I am going to register the targets, in this case, our EC2 instances. Once the targets have been registered, I will go to the load balancer page again and do a refresh. As soon as you will refresh the page, the new target group you have just created will be visible. Now, I am done with all the configurations and our load balancer is ready to make HTTP requests. For that, let's copy the DNS name of the load balancer and try to access our application. Here, you can see, I have not provided any public IP of the instances. Still, our application is accessible. If we do continuous browser refresh, we can see the traffic is getting distributed to both the instances and a request is being served by both the web servers. We have completed the application load balancer demonstration part here. I hope you have understood each and every step we followed during the ELB setup. If you have any questions or concerns or you have been stuck anywhere while the setup, please do let us know in our comment box or through email at myextraclasses@outlook.com. Thank you so much for staying with me in the Amazon ELB demo. I will meet you in the next session. As of now, I will be updating all the steps followed and commands used during our session in the description. Please do have a look. If you are interested in having a one-to-one AWS training session with my extra classes, feel free to contact us via email or directly call us on 0124 4031 061. Happy learning!